electric field and the magnetic field by turning knobs.
Wow.
Okay. Now, on part B, determine an expression from the initial magnetic field on the particle in region 2 and state its direction. So, here's the story. Particle leaves, travels through in a straight line. For each of the following, express the algebra in terms of E1, B1, B2, and the fundamental constants as appropriate. So, there's two things that when you enter B2, what do you not have that you had in region 1?
Electric field.
You don't have the electric field anymore. Also, which direction is the magnetic field
Into the
pointing?
page.
Inward. So, now, when it crosses into this second region here, so let me draw that. Okay? Boom, get dots. And then there's your B1, and here's your B2. Okay? Cool. You have a positively charged particle going into here. Magnetic field is going. So what direction is it going to force it? Upward. So it's going to curve like this. Is it always going to curve like that?
No.
Wait.
It's going to spin in a circle.
Wait till my curve.
Is that actually the right answer?
Wait till my
It might
curve.
spin in a circle.
What?
Because your force, no matter what you do with it, is always
Keeps
pointing
going like
inward.
this.
Oh, it might travel in a circle.
Oh dear.
Oh, how cool would that
Wait,
be?
Bert, why did it curve? Why wouldn't that just go up?
Because let's say it starts to go up. Now your velocity vector's pointing like this. Right? Magnetic field is still pointing in. So no matter where I go, where my thumb points, that force is always going to be acting towards the center.
So what is an orbit?
Nathan, what goes up?
Right?
And then back up again.
All right. So for B, here's the story. Now you only have to worry about the magnetic field strength. So how can you calculate the force created by the second magnetic field? QV. B now, yes, the second magnetic field, so this is going to be QV
B2.
B2. Okay? Hold on.
Okay.
But it says an expression for the initial magnetic force on the particle in region 2 and state its direction. So, we just said that the velocity was what? What could you put in here for that velocity? E over B1, right? Simple substitution. Times B2 times Q is going to equal force 2. Okay? Now, of these, Ek times the ratio of B2, B1 is going to equal that second force if you wanted to get fancy. Okay? Because it says, derive an expression from the initial magnetic force on the particle in region 2 and state its direction. So there you go. Okay? So all I did was substitute, because we know how to get V. Okay? So all I did was just do that substitution. Now, describe the changes, if any, in the magnitude and direction of the magnetic force as the particle moves into region 2. Okay? So as it goes around, are you going to change the magnitude of the force? No. What about the direction?
Yes.
It changes, but which direction does it always point?
90 degree
Towards the center.
At a 90 degrees to the velocity vector, otherwise known as centrifugal force. So you're going to make this thing move in a circle created by the force from the magnetic field. So when you get to D, it says describe the path of the particle in region 2. What's it going to look like? It's going to look like a circle because the magnetic field is making it travel in a circle. Now here's the tricky part. Derive an expression for the charge to mass ratio Q over M of the particle. Specifically noted in quantities not previously defined that are included in your answer. Now, what's the magnetic field from part 2? What's that? The force from that is going to equal what? The centripetal force? Because that's what's going to make it move in a circle, right? True? Everybody cool with that? It's going to move in a circle. So, the force there is going to be Q V1 B1. That's what's going to make this happen. Okay, I'm sorry. That's B2. Okay, that's B2. B2, chill out. It's B2. Okay. Now, that's going to equal M velocity over R. But this is the velocity when it's coming out of region 1.
Wait, can we delay the velocity?
Oh, I don't know. Could we get rid of the
Are they
velocity?
the same velocity?
Yeah, that's velocity. 1, 6,
6,
7,
7,
So then I've got QB2 equals MV over R. Okay. Now, if you really wanted to get fancy, what do you do if you multiply mass by velocity?
Momentum.
Bro.
Bro.
Reach.
Okay.
That's too much. Why would you do so
This is a bit
much?
of a reach, bro.
Now, just chill out. I'm just saying I just threw that in.
Let's not do that.
So you want the charge to mass ratio. So you want Q over M.
You just divide by.
So what are you going to get when you get when you get Q over M? What do you have? V over B2 R.
Okay.
But what can you substitute in for that velocity?
E over B.
E over E.
What?
Bro. You're doing too much.
This is.
Okay. So how can you rewrite that?
E over B1
No.
E over B1 B2 equals Q over M.
It's really good.
Now, here's the ultimate end game, and this is how we find the mass of electrons and protons.
Oh.
If you know the charge,
Yeah.
and if you can measure the strength of the electric and the magnetic fields, you can find the mass of the particle.
So
That's
do
how
I-
you find the mass of the particle.
Do I have to do that on the test?
Oh, absolutely. I promise you. There is going to be a free response question like this. I promise you.
Or you have to like find
It's not going to be the identical one, but it's going to be similar to it.
Wait, if we can find what? We can find what?
If you know the charge,
Right.
and if you know the electric and magnetic fields,
Mhm.
then you can solve for the mass of the particle.
Very
And
good.
that's how you find the mass of electrons and protons. What?
How did they get the charge?
That was that milk and oil drop experiment.
Milking. Whoa.
We watched the video.
You have your last division.
He doesn't pay attention to class anymore, I forgot.
For Cam,
What?
for B, how do we like when it says state its direction? What do we say?
Well, you're just going to say that it's inward at a right angle to the velocity vector.
Oh, that's all I say.
Yeah, that's all you have to say.
Oh.
Okay. So, the next one. So that was one big problem.
Bird, Alyssa.
What?
We shouldn't.
How did we get from E over B1 over B2 R to E over both?
Because I'm dividing by B1, all I did was just shift B1 down here. So that's how it became E B1 B2 R equals Q over M.
What is
Why am I doing what?
All
They were
right,
doing that.
so try the 2009 question with the metal rod. Okay,
No. No. Shut up.
give that one a try.
Hey, I bet I can give this one a shot.